discussed that. But let's go even further back. Okay, so on your way in the door, you picked up a study guide. And bless my heart, I was blind. So the first page of the study guide is seriously already on the back of your notepad, but the back page wasn't. That's why I gave you a whole separate page. It's just going to be okay. The tree will forgive me. I was going to copy the back side anyway. Might as well do front and back. So it's just going to have to be okay. We're just going to roll with it. So you already have your study guide in your hands. Do I expect you to do that this weekend? No. We're going to work on class on that Monday. You have all class period Monday. But you know what people have done last time? I think Mackenzie did, but I don't know if I can throw under the bus like this. But I think Mackenzie had it mostly done, and that was she could ask me specific questions. For instance, if you're still stuck on piecewise, I might get all the other parts done, not the piecewise, and you could ask me about that on Monday. Yes, ma'am.
All of these on the back what we did yesterday?
They're all on the back of what we did yesterday, yes.
When did we do these?
Those are the piecewise. If there's two pieces, they're going to be piecewise. So Natalie's asking a good question because the directions don't specify. Piecewise involves pieces, so if it's got 2 or 3 pieces, it's a piecewise. If it's got just the one thing, it's probably what we did yesterday. That's a good question because it doesn't specify on the study guide. But again, that I see Arturo working hard on it, and he needs to slow down because that is seriously Monday's problem. He needs to get his today homework done before he worries about Monday's issues. Okay, table 6 out of point. My gosh, you're on it. Okay. And 4 out of point. Well, okay. Oh, and 2. Oh, I had to give me all one. Y'all have all your stuff out too. Okay. And 1, you have all your stuff. That's how you realize you sit with them today, not allowed. First of all, we're going to all do 6 Monday. And then second of all, you're going to get whatever points they get. Do you want to be with them or you want to be with them?
When's the study guide due?
Okay.
Tuesday?
What day? Tuesday. Okay, so back on 0. Okay, so if the sooner you let me talk, the sooner I'm not babysitting you, the sooner I could probably just move you to 5s. I don't mind everyone in on 5s every day. It really doesn't hurt my feelings. It would make me happy, actually. Make my life easier counting, that's for sure. Let's see about these 2 math workshops really fast, and then we're going to finish up our notes. But we did the hard part yesterday. We did the hard part of transformations yesterday. We're doing the easier part today, although there is something I do need to show you with the calculators. Okay, so number 13 of the math workshop says Gloria and Sarita are solving the systems, and they gave you 2 systems. Is either of them correct? Explain your reasoning. So, even if you don't understand systems, you can still read through their math work. So let's see. Gloria did this. Somehow she got 3, -2. Sarita did this. Somehow she got -3, -11. Does anyone have any thoughts on if it's Gloria or Sarita or neither? Arturo thinks Gloria. Anyone think Sarita? Yes, ma'am.
Could I please have Alex Warner to the main office for a moment?
Yes, ma'am. Instead of just punishing you, I'll just reward all the others. Every other group except 1 out of point. Okay. So I kind of think maybe Gloria's right just because a bunch of people say Gloria, but I'm really not sure. So once my camera focuses, let's look through what she did. So she set up these 2 equations, 6x minus 4y equals 26, and then she had -3x plus 4y equals -17, and she went straight down. She said 6 minus 3 is 3x. -4y plus 4y, those 2 terms canceled out. That's why she didn't have a y term below. 26 minus 17 is 9. So she ended up getting x equals 3. She took that value of 3, and everywhere, so her top equation used to be 6x minus 4y equals 26. But everywhere in that top equation where she used to have a 6, she plugged in a 3, because she found out x equals 3. So 18 minus 4y equals 26. She subtracted 18 from both sides. She got -4y equals, that didn't cancel out, -4y equals 8. She divided by -4, got y equals -2. Gloria does look pretty legit. So I kind of want to say Gloria is correct. But you know, at the same time, I'm questioning, is Sarita wrong? So let's look through Sarita's work and see what she did. So, -4y plus 4y, those canceled out again with her. She has 6x minus 3x equals 3x. But something went different over here. When she did 26 minus 17, she got -9. Should she have gotten -9? No. So that's why Sarita's wrong. And you could say Gloria's correct, 26 minus 17 equals +9. And that's where Sarita messed up. So in fact, you could circle where she messed up at and maybe like draw an arrow if Gloria was correct. But even if we didn't understand how to solve a system, which you should because you did in Algebra 1, but even if you've forgotten how to solve a system, we can still pretend like we're Miss Compton, like you're a math teacher. Look through their work, try to figure out where they went wrong. And that's that. Are there any questions on 13? Okay, I'm going to be super impressed if you have a 14. It doesn't break my heart if you don't. You have a solution set with all three?
Oh, yeah.
Okay, I don't, do you?
Go ahead.
Okay, we talked yesterday about something to do with that third equation. Can you at least tell me that? What were we going to change about that third equation? Yes, Braxton? We were going to put in y equals mx plus b. So we were going to subtract 2x from both sides, and we would end up with, if you subtracted 2x from both sides, you would end up with y is less than or equal to -2x plus 7. Arturo, will you hand me a green pen so I can have a third color? Okay, so I'm going to graph this line in brown. I'm going to go up to 7. I put my intercept. Thank you, dear. And then since my slope is -2, I go down 2 over 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And this is a weird scaled, the thing they gave you is weird. The viewing window. You know, you and I are used to -10 to 10, so they did a really weird one today. Okay, but this part you do know, and it's an easy point. From here, here's your chance. Do I connect the dots? Do I have a solid line, or do I have a straight, or why?
Because it's equal to, I mean, less.
Or equal to. Yes, it was less than or equal to. So you get a solid line. I heard it from a lot of groups. So all the groups, I did not hear it from 4, no offense. Mackenzie, did y'all say it and I didn't hear you? Okay, so Mackenzie doesn't lie normally. So every group can have a point for that. We're going to let Seth, Miss Compton cannot connect the dots again today. Woo! Struggle's real. Connecting dots 101. Cannot do it. Okay, Seth, I'm going to let your group answer this first, and then I'll let everyone else try. It's less than or equal to. Am I going to shade down here or up here?
You're going to shade to the right.
I'm going to shade to the right or to the left. Where's below? Is it down here or is it up here?
No, that one.
Okay, so your group can have a point for that. So we're going to shade down here. Now, if you're using pencil, you realize we're about to graph and shade 3 different things. So we're going to look where the darkest overlap is. But you know me, I like colors, so I just look for where do the 3 colors occur. Because I'm a color girl. Okay, so I'm going to do this. I'm going to go reverse order. Well, let's do this next one first. So it was y is greater than or equal to 2x. What is the understood intercept on that equation? 0. Eduardo said it so fast. He can have a point for that. His group can. So I put my intercept at 0. I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2, left 1. And there's my y equals greater than or equal to 2x plus 0. Since it's greater than or equal to...
It's a solid.
Oh, Mackenzie said it so freaking fast. Mackenzie gets her point. Arturo was right behind her. Arturo gets another point. Greater than or equal to let Arturo keep the point, he's going to tell me. Ignore the brown. Ignore the brown. If we could completely erase the brown and it was just your coordinate plane in that green line, would above be over here or would above be down here? Where would above be? Okay, so if we shade over here, if we're being smart, notice so far this little region that kind of looks like a house is where I've colored both green and brown. So that's where our true solution is going to be. So I shaded above here, but notice this overlap between green and brown. That's going to be our true solution because that's a solution set they both share. But in fact, I can't even say that. We're not quite done. We still have one more line left to graph. X is greater than or equal to 0 is on that y-axis exactly. So this is x is greater than or equal to 0. But since it's greater than or equal to, if we could erase, I don't know why I made the lines keep extending. I didn't make any of the others extend. Okay, if we could erase the green and the brown and everything else we've done and just have that straight line, would greater than be to the right or would greater than be to the left? It would be to the right. So if we shade it to the right, you're like, Miss Compton, this looks like a hot mess where we just stinking colored everything. And I agree. However, there's this weirdo region where all three overlap. What shape does that weirdo region make where all three overlap? That was the fastest I think you've ever answered. You can have a point for that. This triangle right here is where all three overlap. In fact, I'm going to color it super dark. That is where all three overlap. So we shaded the green, we shaded the brown, we shaded the purple. We looked to see where we had green, brown, and purple, and it's just this triangle. And we're in a hurry, so we're going to let go of part B, but you could totally handle it. I mean, obviously 0, 0 is one vertice. No, I'm lying. We're going to handle it. You could handle it in 0.2 seconds. Never mind, that one looks like it's at a half. Maybe that one's hard. Maybe 1.5, 2.5. So I could see how this part would take you a minute, but they would just want the 3 points, main points on the triangle. Are there any questions about number 14? The ones on your test are not where you have to graph multiple inequalities at the same time. Like our note, you only have to graph one inequality at a time. Okay, let's go back to the page we started on yesterday. Let's go back to 27. That's a lie. We completely handled 27. We completely handled 27. Let's flip to page 28. Oh, we handled 28. But if we look back over it, and we reminded ourselves what we were talking about yesterday, we can translate a function, which means we pick it up, move it left, right, up, down. We can reflect a function, which means we flip it over. And we can dilate a function where we either make it fat or skinny. I told you something makes it fat. What was the key word? The what goes fat. Something, I said, remember this phrase. Something makes you fat. What was the something? Fractions. Fractions make you fat. So, and Natalie gets a point for that. So, if you have a dilation and you see a fraction, it is going to make you fat. Okay, I got in a hurry yesterday, because we all did. And I want to go back to, before we handle what we're supposed to handle today, I want to go back to the ones that I asked you to handle. Let's look at 6 and 7 on page 31. 6 and 7 on page 31. I know that some people have it handled and some people didn't. So, if you graph it... Oh, that reminds me. Let's talk about one other thing. There are different kinds of calculators the way there are different kinds of phones. Some phones are newer, and you know how you have to know what the old phone needs. If you have a black calculator like this one, if you're borrowing a black calculator like mine that's an 83, if yours is a TI-83, when you do absolute value, you have to just put it in parentheses. It doesn't actually show up with bars. You have to use an 84 to get the pretty bars. It's not a big deal. ABS parentheses x plus 3 is the same thing as the bars. But if you're using a black 83, I forgot about that little exception yesterday, it doesn't actually show up on your screen with the bars. Let me show you. So we talked about yesterday, you go to y equals. Come on, autofocus clock. Okay, so you go to y equals. You want to type in absolute value, so you pressed math, you scrolled over to NUN, you saw ABS, you pressed enter, and if you have an 84, which is a yellow one, immediately when you pressed ABS, it did bars inside. But if you have a black one like I'm using right now, it only shows up the letters ABX. But if I press X, which we discussed was this button, and then plus 3, and close my parentheses and graph it, lo and behold, I'm still getting the same graph. But bless your heart, since it's an older calculator, it's not as fancy. You don't actually see the bars on the Y equals screen. You just see ABS in parentheses. But it still gives you the same graph. So if you end up with a black calculator, because you know these are communal and they're not yours, so you got to take what you can get in life, you got to be ready to use it in that way. Okay, so what I should have typed in is 3 math ABS X, because that was our problem on number 6. If you do that and you graph it, you end up with this skinny thing. And so you're like, Miss Compton, I understood yesterday the parent function was 1, 1, you know, over 1 up 1, over 1 up 1, and it was easy. But I don't understand how I'm supposed to do that on my paper. Well, we discussed you could press trace, and that helps you follow specific points around on that V. So what someone said second period, which I don't know why that didn't come to me first, was you could always look at the table. If you press seconds and then table, it's by the graph button, it'll show you the actual table of values. So for instance, 3, 9 is a point on the graph, so I could go over to 3 up to 9. Or if I look at my calculator again, I see 2, 6, so I could go over to 2 up to 6. 1, 3, I could go over 1 up 3. And you can look on the table and it literally tell you what points to plot on your graph. So like if I go down to 0, it says to do 0, 0. It says to go negative 1, 3, negative 2, 6. Negative 2, 6, negative 3, 9. And that's great. And if that's how you want to handle this graph, you can. But I specifically remember discussing with Natalie that she can still do this in her head without using the graphing calculator anyway. Okay, so if we didn't use the graphing calculator, and we were just using our brains, our God-given brains, if we were just using our God-given brains, then you understand it used to be over 1 up 1. Well, instead of going over 1 up 1, we multiply by whatever number's out front. So instead of going over 1 up 1, I go over 1 up 3. Instead of going over 1 up 1, I go over 1 up 3, over 1 up 3, over 1 up 3, over 1 up 3. So you can handle it that way and use your God-given brain. Or I don't know if Arturo just looks at the table on his calculator to get his points. As long as his graph is correct, I really don't question his life. Okay, so on this next one, Arturo could graph it in his calculator. He could graph it in his calculator. I can't seem to graph and talk at the same time. He could graph it in his calculator and look at the table of values. That's one way he could get his points. And he would see, again, fractions make you fat. So this graph is really a lot fatter. But like I was talking to Natalie about yesterday, if you don't need this and you're not going to look at the calculator because you're just this good, you understood, yeah, it starts at 0, 0. But instead of going over 1 up 1, we multiply by that number out front. So we're going to go over 1 up a half, over 1 up a half, over 1 up a half, over 1 up a half. And instead of going over 1 up 1, you go over 1 up a half. Same thing on the other side. And you can get your V like this, and then you would only be using your calculator to compare. Like, am I crazy? No, I'm not. It was supposed to look like this. Okay, because I left you those two yesterday, and then I felt bad about it because those are our only 2 dilation problems. So if I didn't go over it, then what's the point? But, you know, Patrick's trying to get a high score, so who knows. Okay. Are there any questions about these, the dilations? Okay, then let's flip back to the page that we skipped. I want to go to page 28 at the bottom. 28 at the bottom. It was the one with all the notes that we kind of summarized. Today I'm not even graphing. I know I just graphed, but I'm done graphing. Today I'm just describing. So I want to describe what was the parent function and what happened to it. So look at this number 1. Who was the parent of this graph? Who is the parent? We talked about 3 different parent functions yesterday. Who's the parent? Is it absolute value? Is it linear or is it identity? Or which we call linear, or was it constant? Look at our problem. Because of those bars, you know I should write
Absolute
what?
value.
I should write absolute value.
I didn't say it.
You said 4 at first, so come on. Okay, we said absolute value, and we're supposed to describe the transformation. So that plus 4 on the outside, how does it make us move? Up 4, down 4, left 4, right 4. If it's a plus 4 on the outside, it makes us move up 4. And if you need a gentle reminder, if it's happening on the outside, it makes you move up if it's positive. It makes you move down if it's negative. If it's happening inside the bars or inside your function, it's the opposite of what you think. So you would think that negative 4 would move you left 4, but no, it moves you right. You would think that plus 4 would move you right, but instead it moves you left. It's the opposite of what you think inside the bars. It drives you crazy. Gentle reminder. We discussed that yesterday, but I get you slept since then. I don't know why that's permanently ingrained in my memory, but it is. Okay, I've got some still writing. I'm going to let them write. But if you want to go ahead and look at number 2 on the next page, that's where I'm headed next. Who is the parent? The minus 5, how does that make it move? I would love, if Kelsey, say it again. It makes it move down 5, and who's parent? It is a linear. Your group can have a point. It's a linear parent, and it makes you move down 5. Okay, another group want to get a point, number 3.
Absolute.
It is absolute value, and the plus 3 on the inside, how does that make you move? The plus 3 on the inside. How does it make you move? Left, right, up, down?
Left.
Arturo.
Left.
It's left. Because if it's inside the bars, it makes you move left or right. You would think plus 3 would make you move right 3, but it's the opposite of what you think inside the bars. So plus 3 actually makes you move left 3. But again, am I ever taking this bad boy away from you? No. So if you're questioning your life, graph it. Say, oh yeah, it did move to the left 3. You can always check with your graphing calculator. Okay, number 4, who is the parent? Does it have an X? So it can't be constant. Mackenzie, will you save the day? It's linear. And then, how is it being, and I need to not say how does it make it move. I need to ask, how does it make it transformed? Yes, dear. If it was y equals x plus 4, it would be up 4. But that 4 is right next to the x. So how does that make it move?
Just stay on the Y.
It'll go down.
It's not going to be an up, down, left, right, people. We discussed more than just up, down, left, right. We discussed flipping. We discussed dilating things. It could be lots of other stuff. Natalie.
I don't know the answer, but I got a question.
Okay.
What did you say? How you found out if it's linear and absolute value and all that?
Well, absolute value. Natalie is confused on who the parent is, which is a good question because, to be honest, a lot of us are confused. If you see an x at all, if there's an x in your equation, if you see an x at all, it is not a constant. If you see an x but no bars, it's linear. If you see those bars, it's absolute value.
I'm writing that down.
No x, constant. You see an x, it's linear. Absolute value bars, it's absolute value. Okay, Alex. It is not a reflection. If it had that minus sign out front, it would be a reflection. But
Ms. Cox,
yes, ma'am.
may I have a Monday bound switch to the main office?
Yes, ma'am.
Thank you.
This is just a dilation. Okay, so if you and I graphed it, every group will win out a point. If you and I graphed it, the 4, every group but 1 out a point. If 1 adds a point, I'm taking all. The 4 out front stretches me. It makes me a bigger, fatter line. It changes my slope. Didn't we discuss the parent graph had a slope of 1? Isn't that changing the slope? Making it a steeper line? So technically that's a dilation. If it's not there's not a plus or a minus sign, the way there is not a plus or a minus, and you see it's just written right next to it, dilation's your best guess, unless it's a negative sign, in which case it was a reflection. It flipped. Okay, so we get to number 5.
Absolute value.
It is absolute value. but this one has two things going on. What did the minus sign out front make it? Yeah, so it was reflected or flipped. I don't care which word you write. It was reflected, but that minus 2 did something too. What did that minus 2 on the outside do?
Turn into a positive.
The minus 2 on the outside, how did that make it move? Up, down, left, right?
Down.
Down 2. It was reflected and moved down 2. Okay, we get to number 6. It's got a whole bunch of junk going on. Let's start with, it's an absolute value. The 1/5 out front, what is that going to do? It is going to make it fat, so we're going to say it dilated, but if you want to put makes fat, I'm not going to be mad. Okay, then the minus 1 moves me left, right, up, down. Right 1. And then the plus 3 on the outside makes me move up, how many? Oh man, so there's a lot going on in that one. It reminds me of a problem you worked yesterday, number 5. It reminds me of number 5 from yesterday, where it was reflected. It was moved left 1. It was moved down 2. It reminds me just like that one. But we're just describing it today. And it has done. And then we've made life hard. Number 7. Why is life hard on number 7? I mean,
It's got a number behind it.
yes, I know this is absolute value.
Okay, what's that?
Yes. I know if it was written like this,
Don't you go to the next balance?
it was written like this, then you would say, oh, Miss Compton, that's a dilation. You move down 4, you move, it's plus 2, so left 2. I mean, I'm with you with the left 2 and the down 4, but the 6 isn't outside the bars. This time the 6 is inside the bars. So, smart person we are, I would probably go to my graphing calculator and be like, what on earth would that look like, graphing calculator? Can you please show me? So, let's see. So, absolute value, I'm supposed to have 6x plus 2. I'm supposed to close my parentheses and then have minus 4. You better make sure you don't put that minus 4 inside the bars. Then you press graph. Oh, it still made me skinny. That's surprising. No. So I would still say it was dilated. And I would still say that it was moved. But was it for sure moved left 2 and down 4? And can we check that? And we can.
Zoom in.
We could press trace. We could zoom in, but I'm going to press trace and just ask it about those specific points you and I are mad about. We thought it moved left 2 and down 4. So we would think negative 2 would be a value of 4. And it's not. At negative 2, it's 6. So I get you and I are really confused on this one. And I'm really mad at them for putting it in the notes to begin with, if you want my honest truth. So we're going to change it to this with the 6 on the outside. We're going to say dilated, left 2, down 4. If you see any weirdo ones like number 7, go with your calculator, graph it from your calculator screen. It's an abnormal one. Avoid at all costs. It's not following our normal directions. And all because that 6 made it inside the bars. That stupid 6 made it inside the bars, and it changes your whole life. So if you have one to graph like that, no big deal. But if you have one to describe like that, these descriptions that we've written don't actually describe the real number 7. These descriptions we've written describe our fake number 7. Okay, Natalie, you had a question.
Okay, so for it to be right, I'll go back to your rules or whatever
Yes.
with the up, down, right, left.
Uh-huh.
Would that be the only thing that the problem gave us? Like, it's just the bars and the X?
Okay, I'm going to answer Natalie's question. If I were you, you've still got like 10 minutes or so. Start page 32. To be honest, these are super fast. You could probably finish 32 through 34 in that little bit of time.
Like, would it just be that?
No. I understand. It's minus 4, but inside the bars.
So
like,
if
if
everything would be inside the bars?
Yes, for left or right, it's inside the bars. But if it's positive, it's left. If it's negative, it's right, which is the opposite of what you think. Because in your mind, you're like, positive would be right, because that's the x values are positive to the right.
Okay.
It's opposite of what you think.
Okay.
Okay, you have lots of things to work on. I would love to move every group to a 5, but you know that depends on what you decide to do the next 10 minutes or so.